Good evening children, welcome to Turito, the school foundation program for class 8th, and in the previous class we have seen some of the questions related to the fundamental particles at advanced level. So after the discovery of fundamental particles like electrons, protons and neutrons, then scientists start looking at these arrangement of these particles within the atom. How would be the structure of the atom? And in that structure of atom, how these particles are arranged. So all these questions were raised in the minds of the scientist, and based on the assumption and based on the experimental evidences that the scientists have, they started proposing the models for explaining the structure of the atom and arrangement of these particles. So today in our topic, let us focus on the atomic models, okay, especially the how the atoms exist and how the how the electrons and protons and neutrons are existing in the atom, how will be the structure of the atom, all these things we are going to discuss today, okay. And of course so many scientists have tried their level best to give the structure for the atom, okay. They have tried level best to give the structure to the atoms, but of course some of the atomic structures were got the importance, where they have got the attention from the world, and those are we are going to discuss today, okay. So the atomic models after the discovery of the particles like the subatomic particles. Subatomic particle means these are the particles which are present within the atom, okay. Subatomic particles like electron, protons and neutrons. Dalton atomic theory, the Dalton's atom was no more indivisible. According to the Dalton, when you observe the Dalton's atomic theory, what is the concept given by Dalton? Dalton say that atom, every matter is made up of very extremely small particles called atoms, and atom is indivisible, okay. Atoms of an element are alike in all its properties. Atoms of different elements are different in their properties. So these are the concepts given by Dalton, okay. So according to Dalton, atom is indivisible, which further cannot be divided, okay. But of course as the discovery of proton and electron by J.J. Thomson, proton by the Goldstein, proved that atom is further containing some more particle, subatomic particle. So it clearly indicates that atom is divisible, okay. Atom is divisible. We can further divide the atom into smaller particles like electron, proton and neutron, okay. So therefore Dalton atom was no more indivisible. Now it is divisible. Divisible in the sense it consists of some more particles, electrons, protons and neutrons, okay, right. It was suggested that an atom consisted of subatomic particles carrying positive, negative charges, and after the discovery of all these particles, it clearly indicated that the atom consisted of subatomic particles which are going to carry positive as well as negative charges. So the positively charged protons, negatively charged electrons are present within an atom. So this is what the concept is given from the discovered from the the fundamental particles or the subatomic particles, okay. Now different atomic models were proposed, okay. So different scientists, according to their knowledge, according to the experiment that they have carried out, according to their assumption, their thinking, their imaginations, okay. So different scientists have given different atomic models were proposed, okay. They have proposed in front of the world, so that of course if the most of the people agree with the concept, it is acceptable. If it is most of the people are disagree, then automatically it is ruled out, simple, okay. So many scientists have given different atomic models were proposed to explain what the distribution of these charged particles and the arrangement of these charged particles. So now within atom consists of proton and electrons, okay. So one is positively charged, other is negatively charged, and these particles are present in the atom, okay. These particles are present within the atom, and within the atom when these are present, how these are distributed, okay, and how the distribution is taking place. Either distribution is taking place in a uniform fashion or they are concentrated in one area, etc. Okay, how these particles are arranged in the atom, how these particles are kept in the atom, where they are exactly present in the atom. So these things from different scientists have led to different atomic model propositions. So since the proposed models there are so many models that are proposed, but very few are got very interesting are the attention to from the world. Of course, we are going to discuss only those concepts or those atomic models. Okay. So let us move on to the atomic models. The first atomic model was given by Thomson. So Thomson model of atom, and then Rutherford done some experiments, and Rutherford model of atom came into picture. So what are the experiments that are done by the Rutherford we are going to discuss. Then we have after the, of course, each and every model has some drawbacks. Okay, Thomson model has some drawbacks, so the Rutherford model of atom was taken into consideration, but Rutherford model of atom also got some drawbacks. In order to explain those things, one more scientist has proposed some more corrections, that is Bohr has proposed this model. Of course, it has overcome the drawbacks of these two models, but of course still it has some more drawbacks. And then the quantum mechanical model of atom is proposed. The atomic model what we are using today is the quantum model of an atom. Okay, based on the quantum mechanics, the model was proposed. Of course, this is the modern atomic model, we can say. Okay, we are, let us start discussing about these models one by one, and how these how the scientists have proposed the models, and what are the concepts that are present in these models, and how we can imagine the structure of atom. All these things let us discuss one by one. Okay, yeah. Thomson's atomic model. First one, Thomson atomic model is also called as watermelon model, or it is also called as Raisen pudding model. Watermelon or Raisen pudding model, because he has proposed the model in such a way which is going to represent the watermelon, or it is going to represent the Raisen pudding. Okay, so therefore the Thomson's model is considered as watermelon model and also Raisen pudding model. Yes, J.J. Thomson believed that an atom is made up of positively charged substance in the form of a sphere. So he has imagined that the atom is sphere, and this total sphere is made up of only positive charge. So this is how he has imagined the atom. He believed that atom is made up of positively charged substance, okay, in the form of a sphere. In the form of a sphere, the atom is made and it is having a positive charge. This is one point that is observed. Okay, he believed that atom is made up of positively charged substance in the form of a sphere, right? I think you know the structure of sphere, right? And into this sphere, what are there? Embedded electrons. Electrons are embedded into the sphere. So within the sphere, the electrons are kept here and there. Okay, much the same way as apples are embedded in a apple pie. In an apple pie, how the apples are embedded? The same way, the same fashion, the same way or the same fashion, the electrons are embedded within that positively charged sphere. Able to understand? Right. So this is how he has given the concept. Furthermore, he said that the total positive charge of the sphere is equal to the total negative charge of the electrons. What he says? So he said that the sphere is made up of, atom is in the form of a sphere with a, it is made up of a substance which is having a positive charge, and here and there the electrons are embedded, and these electrons are having the negative charge. Okay, and he says that whatever may be the total positive charge that is present within that sphere is exactly equal to the total negative charge. Why he said like that? He has given the concept that positive charge equal to the negative charge in order to say that the atom is electrically neutral. We know atom is electrically neutral. Atom is neutral in nature. Okay. We know, we have already seen atom when it is going to lose an electron, it will convert into a positively charged ion, that is cation. Atom when gains an electron, when it takes up an electron, it converts into its corresponding negatively charged ion, that is called as anion. So, in usual, if you observe the atom is electrically neutral, it does not have any charge. Okay. When atom loses an electron, it converts into a positively charged ion, we call it as cation. Okay. An atom when it gains an electron, it converts into a negatively charged one, that is known as anion. Okay. So, it is converting into an anion by gaining electron. A neutral atom converts into cation by losing the electron. So, here the charges are present, positive charge and negative charge present on the cation and anion. But if you observe the atom is neutral, it is electrically neutral. Electrically neutral means it does not have a positive charge or it does not have a negative charge. So, in order to explain this neutrality, Thomson observed that, or he said that the total positive charge of the sphere is exactly equal to the total negative charge carried by the electrons. Okay. I think you got a clear idea now. Okay. So, the sphere having the positive charge, here and there the electrons are embedded which are having a negative charge. Total charge on the sphere, that is positive charge, is exactly equal to the total negative charge because of the electrons. Okay. Total negative charge present on the electrons, and because of the total positive and negative charges are equal, they get cancelled out. Electrical on a overall remain neutral. So, the atom will remain overall as a neutral. Okay. So, in order to explain the atom's neutrality, the total positive charge and total negative charge are assumed to be equal. Okay. Right. Let us imagine how we can see the atom according to Thomson concept. According to the Thomson's concept, atom is spherical in nature. How it is? It is spherical in nature, and moreover it is positively charged. Atom is spherical in nature and it is positively charged sphere. And if you observe here, the electrons, negative charge electrons are embedded here and there. So, this is how Thomson has assumed the atom for explaining the arrangement or distribution of these fundamental particles, electrons and protons. Okay. So, here the sphere is having positive charge. So, the total positive charge is exactly equal to the total negative charge of the electrons. That is how the atom is said to be a neutral species. Atom is said to be a neutral because of this presence of positive as well as negative charge. Total positive and negative charge is equal. Okay. Yeah, you can imagine Thomson model as watermelon model. Just take one watermelon and cut the watermelon into two pieces. Take watermelon, cut into two pieces, and then observe what you are going to see in this particular half of the watermelon. You can clearly see that the half of the watermelon you can see in this fashion, right. So, if you observe here, the same way Thomson assumed that atom, the total red colored portion here, if we observe, the total red color portion is taken as a sphere of positively charged one. Okay. And the black seeds, the seeds that are present in watermelon, the black seeds, of course, when you observe the seeds, they are embedded here and there, right. So, within the total red portion is taken as a positively charged sphere, and the black seeds are taken as electrons, and because of the total positive charge is exactly equal to the total negative charge of the electrons, the atom is said to be neutral. Okay. So, you can imagine the presence of the red portion in the form of a positively charged sphere, the seeds in the form of a negative charge. And if you observe, this is the center. Okay, this is the center of the atom. From center to the outer portion, this is taken as the radius. So, here what is R? R is the radius of an atom. radius of an atom. Okay. So, it is radius of an atom and it is in the order of 10 to the power of minus 10 meters. It is in the order of 10 to the power of minus 10 meters. So, within 10 to the power of minus 10 meter is the radius of this particular atom according to the Thomson concept. So, here in the case of watermelon, the red portion, whatever may be the red colored portion that we see, is taken as a sphere of positive charge. Okay, sphere of positive charge. Okay, and the black color seeds, of watermelon, they are considered as the negatively charged electrons. They are considered as negatively charged electrons. So, thereby we can easily compare the Thomson's model with a watermelon model. So, it is known as watermelon model, or you can also consider it as a Raisen pudding model. Generally, when you observe in the bakery, the bread is bacon, and then here and there they are going to keep the puddings. Okay, the puddings arrangement is taken as the electrons arrangement, and the total bread, the cake, is considered as the sphere of positive charge. You can also imagine in that direction. Therefore, it is also called as Raisen pudding model. Okay, right. You just observe one more time what is exactly the concept given here. You can see this video again. Right. So, the total red color portion is taken as a positive sphere, and electrons are embedded here and there within the positive sphere, so that the total positive charge is neutralized by the total negative charge, and on overall if we observe, atom is electrically neutral. Right. This is how he has started explaining the arrangement of the fundamental particles, or the distribution of electrons and protons within the atom and the structure of atom. Okay. But this model has some drawbacks. What are the drawbacks of Thomson's model of an atom? Thomson's model of atom was not accepted by fellow physicists. So, the fellow physicists, the colleagues, the scientists, other scientists, at the same time, they won't accept it, they are not accepted the concept of Thomson. How these particles, electrons are embedded here and there, how it is possible? It was unable to explain. Which one? This model, the Thomson model, was unable to explain how a positively charged particles were shielded from negatively charged particles without getting neutralized. We know whenever we have a positive charge, when a negative charge comes near to it, automatically neutralization takes place. Okay. So, in this case, in the case of Thomson model, what he says? He says that the sphere is totally positively charged one, and electrons are embedded here and there, and this shows that how the positively charged particles were shielded from the negatively charged particle. When you know that positive and negative, whenever we have, they get attracted and they will get cancelled out without undergoing neutralization, without getting neutralized, how these particles are remaining in the atom? So, that is a question that is raised by the fellow scientists of Thomson. Thomson does not have any answer to those questions. Okay. So, this is one drawback of Thomson's model. Okay. Since here the how the positively charged particle is shielded from the negatively charged particle without neutralizing each other. So, they will not remain as such in the atom, right, they should get neutralized, but that is not happening. The total sphere is positive, and here and there we have a negative charge. So, negative charge and positive charge is not neutralized, but they are shielding with one another. How it is possible? How this can happen? This does not happen in nature. So, that is what the question raised by the fellow scientists, and thereby the model has could not, I mean, that J. Thomson could not explain the this particular question. Okay. And then One more thing is that at the same time, more or less at the same time, Rutherford done the experiment, alpha scattering experiment. And moreover, if we observe, Thomson model could not answer the observations made in the Rutherford model. Rutherford at the same time done some experiments. The main famous experiment is alpha scattering experiment. In his alpha scattering experiment, he has done the experiment and he has got some observations. So he has noted down the observations. So those observations could not be explained by taking Thomson model into consideration. In other words, we can say that Thomson model of atom failed in order to explain the observations made by Rutherford. Okay. So that is one more drawback. First thing is how these charged particles are shielding one another without getting neutralized, first question, and it could not explain the concept or the observation made by Rutherford. So both are because of these two drawbacks, the Thomson model was ruled out, and then the Rutherford atomic model came into picture. Okay, right. Let us now focus on the Rutherford's model of an atom. In 1911, Rutherford carried out experiments on the bombardment of the atoms by high speed positively charged alpha particle. He has taken the atoms, of course the material matter, and he made the high speed alpha particle. The alpha particles are positively charged. Okay, I will give you what are alpha particles. The high speed alpha particles are made to bombard. Bombard means collide on the surface of the matter. We know that matter is made up of atoms, automatically it is bombarding on the atoms. Okay, bombardment of the atoms with a positively charged alpha particles. So positively charged alpha particle is nothing but the helium nuclei. What is it? Alpha particle is helium nuclei. Helium, hydrogen and helium. The second element in the periodic table is helium. So helium is having two positive charges. Helium with two positive charges is alpha particle. Okay. So alpha particle is a positively charged particle. Alpha particle is a positively charged particle. It is a helium nuclei with two positive charges. Helium nuclei with two positive charges is alpha particle. Okay. So what he did in this case is Rutherford bombarded the thin metallic sheet of gold. He has taken very thin metallic sheet of gold. Gold sheet he has taken. How much thin? You can see here, 0.0004 centimeter thick. That very thin foil of gold is he has chosen for the experiment, and on this thin gold foil he made the alpha particles to hit. He made the alpha particle to bombard. Bombard means he has fired these alpha particles onto this gold foil. So the alpha particles are coming and hitting the gold foil. Okay. So that is how he has carried out the experiment. Where these alpha particles are produced? Alpha particles are produced by a radioactive element, that is radium. Radioactive element, these are the elements which are capable of producing the radiations on their own spontaneously. They are said to be radioactive element. So radium is one radioactive element. Radium is one radioactive element. So radium liberates, or it is going to emit alpha particles on its own. So the alpha particles emitted by the radium are made to fall on this gold foil, very thin gold foil. What is the thickness? It is 0.00004 centimeter thick. Very small, very thin gold foil is taken, and on that gold foil he made the alpha particle to bombard. And in that process, if you observe here, so this is the source from where the alpha particles are produced. So radium is taken in this case, and alpha particles are produced. Alpha particles are shown with a straight line here. So the line, straight line is alpha particle rays going toward the thin foil. Okay. So a lead plate is taken, so that only in one direction the alpha particles are made to hit the gold foil. So this is the gold foil. The middle one is the gold foil. Okay. And the alpha particles hit it, and they pass through and they can hit on the screen. Since alpha particles are not visible to naked eye, so Rutherford cannot identify where they are going. So in order to identify their the route in which they are going, he kept a, what do you call, the photographic plate. Okay, a photographic plate is kept around the gold foil, so that as soon as the particles hit this particular the wall of the photographic plate, a flashlight is going to come. So as soon as the flashlight comes means it indicates that the alpha particles are hitting the screen. Okay, so a screen is kept and the screen is coated with a photographic plate. As soon as the particles go and hit the screen, a flashlight is produced. So the flashlight produced indicates the alpha particles are hitting the screen. That is how he has carried out the experiment. He has taken a source of radium. So the radium is going to emit the alpha particles. So here arrow indicates the alpha particle, they are going in a straight line. In order to make them to move in a straight line, a lead plate is kept in between in their path, so that only one direction ray is allowed. So these rays are going and hitting the gold plate that is kept over there, and in order to identify these ones, a photographic plate is kept, so that the presence of or the movement of or the direction of the alpha particles can be known with certainty. Okay. So this is what the Rutherford alpha scattering experiment is. Okay. Yeah. In order to give you the clear picture of alpha scattering experiment carried out by the Rutherford, you can see here, you can clearly observe here. This is the lead chamber, okay, the blue one is a lead chamber, in which the yellow one is a radium, okay, and it has a hole, you can see here hole, the hole is present in the lead chamber. Through this the alpha particles are going out. So here the blue balls that are coming out are alpha particles. Okay. So a radium is taken, emitting source, alpha particle emitting source, it is kept in a lead chamber and a small hole is made in this case. So the alpha particles can come out easily and then they can go and hit the surface of gold foil. Okay. Just to see how these things are going to shown. This is a particle emitter, radioactive metal, lead box. Alpha particles are produced. Alpha particles are nothing but helium with 2 positive charges. So the alpha particle fastly moving, high speed, like a gun. Okay, from gun the bullets are fired. Now the bullets are going and hitting the gold foil, and a screen is kept. You can observe as soon as the particles go and hit the screen, you can see the flashlight. The flashlight is coming. Okay, are you able to see this in? We'll play once again. Yeah. We have a lead chamber, radioactive element, alpha particles are coming. As I told you, alpha particles are positively charged species, they are coming out and they are made to fall or they are made to hit the gold foil. Like the here from the gun the bullets are fired. Okay, just imagine that here this is a gun from where the bullets are fired. This is the radioactive substance from where the alpha particles are coming out with a high speed. Okay. So the high speed alpha particles made to hit the thin gold foil. You can see again. Yeah, the flow of alpha particle going there. This is the gold foil, very thin gold foil kept in their path, and a screen is kept surrounding the gold foil with the coated with the fluorescent material. So as soon as the particles hit the surface, you can clearly see the flashlight that is coming. And if we observe here, very small flashlights are coming with the deviation. Maximum flashlight is coming in the same direction. So in the same direction, most flashlight is coming. Very small flashlight we can observe from this area and this area. Okay, right. So what is happened exactly? Let us assume atom is spherical in nature. Atom is spherical, as what the Thomson has taken. The same concept you can observe. This is the gold atom. Let us assume this is the gold atom of a gold foil. So this is circled one, the sphere. The sphere what we are going to take is the atom of a gold foil. Okay. Now these are the alpha particles. What are these? These are alpha particles. A beam of alpha particles are coming. Okay. So beam of alpha particle, they are going through the atom. Okay. So, when you see here this ray, this alpha particle going in without any deflection, this alpha particle going without any deflection, okay. And if you observe this alpha particle going and it is changing the angle, it's changing its direction. One more alpha particle going this way and changing its direction. So, very few alpha particles are going in these directions. Most of the majority of the alpha particles, majority of the alpha rays are going in a straight path without any deflection. Without any deflection, most of the alpha particles are going through the atom. And if we observe, this is one, very few alpha particle as soon as it goes straight and it's coming back exactly, it is bouncing back, okay, bouncing back. That is to say that when a beam of alpha particles are fired onto the gold atom, what is happening? Most of the alpha particles are passing through the gold foil without any deflection. Majority of alpha particles are going in a straight line. Straight line means without any deflection. For example, if I am throwing a ball in this room, if I am throwing a ball towards the wall, if somebody comes in between, automatically the ball will hit that person or that object and it will change its direction, right? If nobody is there, automatically it will reach the wall without any deflection. It will go in a straight line. The same thing is happening here. Majority of the alpha particles are going in a straight direction without any deflection. No deflection is going on for majority of the alpha particle, majority, okay. And very few particles got deflected by small angles and a few particles got deflected by large angles. Few particles got deflected by small angles, they have changed the direction by small angle, some are changing the direction by large angles, and very few means 1 in 20,000 alpha particles. If you are firing 20,000 alpha particle, one particle is bouncing back, it is coming exactly back, it is going and hitting and then it is coming back. That is to say that what are the nature of these alpha particles? The alpha particles are positively charged. Just now we have seen that these are the helium nuclei with the 2 positive charges, okay, helium nuclei with 2 positive charges. So, they are alpha particles are positively charged particles. Positively charged particles will change the direction only when we have a positive center in between, okay. So, we know that in nature like charges always repel, unlike charges will attract. So, here the positively charged particle got deflected means we have one more positive particle inside, okay. And one particle is exactly bouncing back means it is exactly going in the straight direction to that positive particle and it is coming back, it is bouncing back, okay. So, these are the observations made during the experiment by Rutherford. Just imagine we are looking into the thin foil of the gold, okay, we are looking at the thin foil of gold. These are the gold atoms, okay, within these are gold atoms present in that foil, okay. Now, from this direction the alpha particles are coming, okay, and observe how the alpha particles will change their direction, how the alpha particles will be going through, passing through the atoms of the gold. Yeah, the red balls are alpha particle, they are coming and they are passing through the atoms without any deflection. You can clearly see here the dotted one, it is going without any deflection, no deflection at all. And if you observe these particles, this particle changing very small angle and some particles are changing their angle by large. You can see here this yellow one, it is going this way. So, large deflection is possible, very small deflection possible. And if you observe the red one, it is bouncing back, it is going back. So, what kind of information we are going to get from this particular experiment? I will play it again, just observe what is exactly happening, okay. So, these are the gold atoms present within the gold foil, okay. So, gold is made up of gold atom, gold is a matter, right, and it is made up of atoms only. So, the atoms are present side by side in the gold foil. Now, the alpha particles are going, now how the process is going on, how the deflection is going on, you can observe. Most of the alpha particles, they are passing without any deflection, you can see most of them are going in that direction. See here blue ones, no deflection at all, and you can observe the green one, small deflection, the red one bounced back. Now, the yellow one got deflected by large angle, large deflection is possible, small deflection, no deflection. So, most of the alpha particles passing through the gold foil without any deflection, first thing you can make it. And few particles are deflected by small angle, few particles are deflected by large angles. This is one more point we can observe. And very few means if you are firing 20,000 alpha particle, one particle is going and hitting and it is coming back, bouncing back. Okay. So, that is how we can see here the red one bouncing back, rebound. So, it is coming back exactly. So, this is how the concept was observed by the Rutherford. So, if we observe the observations, majority of the alpha particles continued their straight path. There is no change in their path. They are traveling in the straight path. Okay, nobody disturbing their path. They are going without any deflection. Some particle which passed very close to the center of the atom, which are going very near to the center, they got deflected by small angles and large angles. That too, few particles, not majority are going without any deflection. Few particles which are going very close to the center of the atom, they got deflected their path through large angles and through small angles. And one more point we can observe, very few means 1 in 20,000 alpha particles thrown back. Thrown back means it is rebounds, it came back without any deflection. I mean, it is to say that 180 degree deflection took place. 180 degree deflection took place for one particle in 20,000. Okay. So, these are the observations made, which we can clearly observe from the experiment what we have seen just now. Most of the alpha particles continued in the straight path, some are which are going very near to the center of the atom, they got changed their path by small angle as well as large angles, and very few particles bounced back, they are thrown back, and that too one particle in 20,000 particles, it is coming back by 180 degree. So, these are the observations made by the Rutherford. We will see the conclusions, what kind of conclusion we can make from these observations, and based on the conclusion, how Rutherford has proposed his atomic model and how it is going to represent, how it will be. So, all these things we are going to look into the Rutherford model in the next class. I think you have enjoyed today's class with respect to the Thomson model as well as the Rutherford model. Once we finish the Rutherford model, we will discuss the Bohr's atomic model as well. Okay. Of course, we will discuss even the drawbacks of Rutherford. Once we propose the atomic model, how it is rejected, what are the drawbacks of the Rutherford, all these things we are going to observe. Okay. I will come up with some more interesting topic in the next class. Until then, have a nice time. Thank you.